everyone, this is Kalpana here. So in this video we are going to see a problem from Fourier series. So let's get started. Problem: obtain the Fourier series for the function f of x equals to e power ax in open interval 0, 2 pi. Solution: here we are given a function. Given function is f of x equals to e power ax in open interval 0, 2 pi. Okay, so the required Fourier series is f of x equals to a naught by 2 plus summation n equals to 1 to infinity an cos nx plus bn sin nx, where a naught equals to 1 by pi into integral 0 to 2 pi f of x into dx, an equals to 1 by pi into integral 0 to 2 pi f of x into cos nx dx, and bn equals to 1 by pi into integral 0 to 2 pi f of x into sin nx into dx. Okay, so first we will find a naught, an and bn, and after applying f of x, a naught, an, bn in this series, we'll find the required Fourier series for the given function. Okay. So first we will find a naught. To find a naught, we have a naught equals to 1 by pi into integral 0 to 2 pi f of x into dx. So this is equals to 1 by pi into integral 0 to 2 pi. We have f of x equals to e power ax into dx. So this is equals to 1 by pi into integral e power ax is e power ax by a, and the limits 0 to 2 pi. So this is equals to, since 1 by a is constant, so we'll take it outside the bracket. So you'll get 1 by a pi into e power ax for x equals to 0 to 2 pi. Now we'll apply the limits. First we will apply the upper limit. So this is equals to 1 by a pi into e power a into 2 pi will be 2a pi. Okay. Minus, now apply the lower limit x equals to 0. We'll get e power a into 0 is 0. So this is equals to 1 by a pi into e power 2a pi minus e power 0 is 1. Okay. Since e power 0 is equals to 1. Fine. So this is equals to e power 2a pi minus 1 by a pi. Therefore, a naught equals to e power 2a pi minus 1 by a pi. Right? Fine. Now let's find an. To find an, we have an equals to 1 by pi into integral 0 to 2 pi f of x into cos nx into dx. So you could write it as an equals to 1 by pi into integral 0 to 2 pi into e power x into cos nx, since f of x equals to e power ax. Okay, fine. since we know that integral e power ax into cos bx into dx is equals to e power ax by a square plus b square into a cos bx plus b sin bx. Okay, so this is equals to 1 by pi into, this is of the form e power x into cos bx into dx, right? In the place of a equals to a, substitute a equals to a and b equals to n in this formula. Then you'll get e power ax by a square plus n square into a cos nx plus n sin nx. Okay, and the limits 0 to 2 pi. Now apply the limits. We'll have 1 by pi into e power a into 2 pi. For upper limit x equals to 2 pi, we'll have 2a pi by a square plus n square into a cos n into 2 pi is 2n pi plus n into sin n into 2 pi is 2n pi minus, now apply the lower limit. Minus e power, for lower limit x equals to 0, you'll have a into 0 is 0 by a square plus n square into a cos n into 0 is 0 plus n into sin n into 0 is 0. Okay, since we have sin 2n pi equals to 0, cos 2n pi equals to 1, sin 0 equals to 0, cos 0 equals to 1, right? Since cos 2n pi is 1, sorry, not 0. Cos 2n pi is 1, sin 2n pi is 0. Then this total term becomes 0. Okay, and here you're having cos 0 which is 1 and sin 0 is 0. So this total term becomes equals to 0, right? So this becomes equals to 1 by pi into e power 2a pi by a square plus n square into a into value of cos 2n pi is 1, right? So a into 1 will be a, okay, plus 0, good, minus e power 0 is 1 by a square plus n square into a into value of cos 0 is 1. So a into 1 will be a. Okay, this is 0, right? Fine. So this is equals to, here a is constant, right? So take the constant outside the bracket, you'll have a by pi into e power 2a pi by a square plus n square minus 1 by a square plus n square. So this is equals to a by pi into e power 2a pi minus 1 by a square plus n square. Okay, so we have, therefore we got an equals to a into 2a pi minus 1 by pi into a square plus n square. We are having an equals to a into e power 2a pi minus 1 by pi into a square plus n square. Now we have to find bn. To find bn, we have bn equals to 1 by pi into f of x into sine nx into dx. Okay. We are having f of x equals to e power ax. Simply replace f of x by e power ax into sine nx into dx. Okay. Since we know that integral e power ax into sine bx into dx is equals to e power ax by a square plus b square into a sine bx minus b cos bx. So compare these two. You are having a equals to a, b equals to n. Now put a equals to a and b equals to n in this formula. So you'll get 1 by pi into e power ax by a square plus n square into a sine nx minus n cos nx for x equals to 0 to 2 pi under limit 0 to 2 pi. Okay. So now you can apply the upper limit and the lower limit. So this is equals to 1 by pi into, now we are applying the upper limit 2 pi. For x equals to 2 pi, you'll have a into 2 pi is 2a pi by a square plus n square into a sine n into 2 pi is 2n pi minus n into cos n into 2 pi is 2n pi minus, now apply the lower limit 0. For x equals to 0, you'll have e power a into 0 is 0 by a square plus n square into a sine n into 0 is 0 minus n cos n into 0 is 0. Okay. Since we have 2n pi equals to 0, sine 2n pi equals to 0, cos 2n pi equals to 1, cos 0 equals to 1 and sine 0 equals to 0. Okay, the value of sine 2n pi is 0. So the total term becomes 0. You are having cos 2n pi here. The value of cos 2n pi is 1. And here you are having sine 0, which is 0. So total term becomes 0. And here you are having cos 0. Value of cos 0 is 1. Okay. So this becomes 1 by pi into e power 2a pi by a square plus n square into minus n into value of cos 2n pi is 1. So n into 1 is n, right? Minus n. Minus n into 1 is minus n. Minus e power 0 is 1 by a square plus n square into, here also you are having minus n into cos 0. Value of cos 0 is 1. So minus n into 1 is minus n. Okay. So this is equals to 1 by pi into minus n into e power 2a pi by a square plus n square minus into plus, minus into minus plus n by a square plus n square, right? So here you can take n common from the two terms. So you could write it as n by pi into minus e power 2a pi by a square plus n square plus 1 by a square plus n square. Again, you could write it as minus e power 2a pi plus 1 by a square plus n square. So here you are having minus and plus, right? So you can change the symbols by taking minus common. Okay, now we'll take minus common. We'll have minus 1 by pi minus n by pi into e power 2a pi minus 1 by a square plus n square. So this equals to minus n into e power 2a pi minus 1 by pi into a square plus n square. So therefore bn equals to minus n into e power 2a pi minus 1 by pi into a square plus n square. So now we are going to find the required Fourier series. We have f of x equals to a naught by 2 plus summation n equals to 1 to infinity an cos nx plus bn sin nx, right? So now we'll substitute f of x, a naught, an, bn values. We have f of x equals to e power ax. F of x is a function, so we have function e power ax equals to a naught. You're having a naught equals to this one, right? E power 2a pi minus 1 by a pi into 2 plus summation n equals to 1 to infinity an. An is a into e power 2a pi minus 1 by pi into a square plus n square into cos nx plus bn. You're having bn equals to minus n into e power 2a pi minus 1 by pi into a square plus n square. Into sin nx. Okay. So this equals to e power 2a pi minus 1 by 2a pi plus. See, here you're having 2a pi minus 1 and here also you're having 2a pi minus 1 by pi common. So let's take it outside the summation. So you could write it as e power 2a pi minus 1 by pi into summation n equals to 1 to infinity a cos nx by a square plus n square plus into minus, minus n into sine nx by a square plus n square. Okay, so this is a required Fourier series. Or you can also take e power 2a pi minus 1 common from these two terms. So you could write it as, so here you can also take e power 2a pi minus 1 by 2a pi common from these two terms. Okay, this term and this term. So this equals to e power 2a pi minus 1 by 2a pi into 1 plus 2a. See, 2a into this one will be e power 2a pi minus 1 by pi. Here 2a gets cancelled. Fine. Into summation n equals to 1 to infinity. Now you can take LCM from these two terms. And you would write it as a cos nx minus n sin nx by a square plus n square. Therefore, e power ax equals to e power 2a pi minus 1 by 2a pi into 1 plus 2a into summation n equals to 1 to infinity a cos nx minus n sin nx by a square plus n square. This completes the problem. Okay. Which is the required Fourier series for the given function in open interval 0, 2 pi. So we have seen a problem from Fourier series in this video. Hope you will understand. We'll see you in the next video. Until then, bye bye.